So we have a hard problem today, and we have grid with some numbers, and we're doing some interesting marking the columns with some color. So we can choose any index at any column and do this marking. After that, we are taking the sum of all numbers that are adjacent to these marked positions, and we want to find the maximum sum when we're doing the optimal choice of marking. Optimal choice. So when you're talking about choice, it is always, most always, very high probability that it is dynamic programming. Now, how can we do this optimal choice? Very quickly, you can see that if you have some matrix, you can take a slice of it like this and say that all this result can be optimized, and then the remaining part is only depend of the next choice. So it depends on these contents, and it depends on the choice or at this border of this slice. Now, this problem is very simple dp of n squared, or I would say it's doable. However, I would like to explain it very short. So how it's doable? Basically, you taking the current column position I on the x coordinate, and you know the previous choice, length, the previous, and you have to also know the grand previous or previous of previous. This is how I would call it. And after that, you iterating the current and you checking if there's some optimum. And basically, if you know what is the optimum, you computing the sum based on the previous of previous, then based on previous and based on the current. So we have three variables: previous, and current. And basically, and this current is also iterating O of n, so you have to do this entire column and picking the best. So you have n cube for the three variables each, and inside the dp you have extra of n. So basically the solution n4. Now I did this and I basically failed this problem, massively failed. Now you can see that I did 9 attempts, then I used all the hints, and finally I looked at all solutions, and finally I resorted to Gemini, and only with the help of it I was able in 1 hour 40 minutes to finish this problem. I basically got some solution, and this solution is n cube, So the O of N4 is time limited exceeded. Now I will shortly explain what is N-cube solution. So if you got what the intuition of N4 solution, basically you have a previous column, and current, and you deciding which or how many items you take at the previous item or previous column. So I-1 will give you the sum. By the way, the sum is a prefix sum. You don't want to calculate it another time in the extra n loop. So the prefix sum is current height of the previous column. Previous column is the bottom line, and current j, where you're iterating for the height, is the maximum. So we're doing calculating this prefix sum of j minus prefix sum of p, previous column. So this is the N4 solution, and there is some property. So if we imagine we have previous height, we have just previous height, and we iterating on the current height to find the best. And basically we have some different conditions. So as you can see, given we have previous is less than previous, that means we take in all items that are between the pp and p, so like this, because they have adjacent of pp. And also can have different situation where our pp is small, and that means we only considering the current column height. It should that should be bigger than previous, because pp doesn't give us adjacent on horizontal position. So basically what we have to, if we are very clever big brains, we spot this situation flips when you have previous bigger than previous or smaller. So if it's bigger, you just take it, and if it's smaller, then you have to consider the current to be bigger of both P and P. And this kind of intuition should have suggested you that you, instead of iterating over all current heights, and we can just make some hard rule, or I would say hard rule that we shouldn't break. So if we only have previous and current and some hard rule, this would be some boolean variable, and that hard rule is if the items in current, if the items are claimed or not claimed or skipped. So imagine I will try to explain what I just you have to know that I didn't solve it myself. So imagine basically if we say that the current height is claiming the current is claiming all the values on a current row or current column. So maybe I'm weak in this explanation. Let's look at the code. So if we skipped on the previous, if our rule is to skip, then we consider the current to be bigger than the previous. So basically the rule basically it can be explained a little bit simpler. Is should we consider, should we keep a current height bigger than previous? This is a rule, and if we say this is a previous column and this is a current column, should we current previous, and current is bigger than previous. This is a rule, and we submit into this rule, and we say that all the values on the previous row or previous column are claimed by the current column, and basically the previous column skipped these values. That's why it's called skipped. And we should and we only allowed to pick the current values to be bigger than the previous. So this is what is allowed. Now let's look at the code. If previous has skipped, then the current should be bigger than the previous one, and we are claiming all the skipped from the previous column. The previous is I-1. So this is how it logically sounds. And we taking this claim from the previous row or from the previous column, and we also considering the next column and picking between which rule would play the best, would give us the best. Should we on the next iteration take it's bigger than the current or smaller than the current? So basically skip can be renamed to bigger. So basically it's the same logic. Now, and the second part is that if it's smaller, skip equals 0 means that the previous column already have taken all the values. Now the current column should be smaller as we submit into the rule, and that means we are taking values from the current column, not the previous one, and we are taking them according to the previous column height. So this is what we take. Now let's look at the code. and we considering only values smaller than the previous one or equal to claim them. This is what we're claiming or taking. The PS is the prefix sums, and this is what we so basically if we this is an extra corner case because we only take in the previous if we skipping, or basically if we, so this is skip 0 and it goes to skip 0 again, and if it's skip 1 we don't take it because we are skipping the current column. So skip is the answer to the question, I will skip it the previous column. So if we skipped, we place in 0 and we take in the current. Or maybe I'm contradicting myself. So we are taking the current, and for the next guy we are saying do not take the previous one, so 0. Okay, I think this has explained it. Now the final solution or final golf is not very interesting, it's just golf, not very interesting at all. So this problem was for me extra hard, because even so I was able finally to arrive to this N4 solution intuition, but I wasn't able to do the logic jump from N4 to N3. And the first attempts are even worse than that, so it was completely broken logic. That's it for today.